Hi Rangers, today we're going to be finishing limits to notes. So we're going to talk about infinite limits. Our objective today is to determine infinite limits from the left and from the right. So graphically, an infinite limit is going to increase or decrease without bound at a vertical asymptote. Okay, so first blank is infinite limit. Okay, analytically, if we do direct substitution, it yields a 0 in the denominator. So we'll get a number over 0. Numerically, substitute a decimal number that is approaching the limit to see if the y values are approaching positive or negative infinity. Okay, and then we're going to be describing the end behavior to the left and the right of the vertical asymptote is useful in that particular function. So if we're thinking about the limit, okay, the one-sided limit, we have two different options on our answer for this. So on a one-sided limit, it's either going to be positive infinity or negative infinity. So what that would look like would be positive infinity. Okay, if we're just looking from the left or just looking from the right. So your graph could look like that. Your graph could look like this, where they're going in the same direction. Again, we're just looking at the one-sided limit. Or the last one, they could both be going down. Okay? So if we're just looking at one side, you have two options, 50-50 chance. Positive infinity or negative infinity. But when we look at the two-sided limit, okay, this is where it gets a little bit trickier, okay, because we no longer just have two options, we have a third option. So if it is one like this first example right here, if my limit from the left is not equal to my limit from the right, then the limit does not exist. Okay, if it's like the middle picture that I drew, both limits are going towards positive infinity, so it would be positive infinity. And the last picture, if they're both going down towards negative infinity, the limit would be approaching negative infinity. Okay, so those are our options. If it's one-sided limit, we're either looking at positive or negative infinity. If it's a two-sided limit, it's either does not exist, positive infinity, or negative infinity. So let's look at our first example. Which graph agrees with this statement? Choose all answers that apply. So the limit as x approaches -3 from the left side of g of x equals negative infinity. Okay, so let's look at answer choice A. As I'm approaching -3 from the left side, my graph is going down towards negative infinity, so that one works. If I look at answer choice B, as I'm approaching -3 from the left side, this graph is also going down towards negative infinity. Perfect. Answer choice C, as I'm approaching -3, this graph is going up towards positive infinity, so that one does not work. Okay. Question number 2. Which limit expression agrees with the graph? Choose all answers that apply. So the limit as x approaches -1 of f of x equals negative infinity. Well, remember, we have to check the left side and the right side. So as I'm approaching -1 from the left side, it's going up towards positive infinity. As I approach it from the right side, it's going towards negative infinity, which means the limit does not exist. So therefore, answer choice A does not work. for this graph. Okay, answer choice B, the limit as x approaches 3 from the positive side, so from the right side of f of x is negative infinity. So as I approach positive 3 from the right side, it is going down towards negative infinity. So that answer does work. And answer choice C, as x approaches negative 5 from the left side, f of x is approaching negative infinity. So as I approach from the left side, it is not, it's going up towards positive infinity, so that does not work. Moving on to the next page, we have some graphs and some limits. I want us to get really good at being able to do this algebraically and not relying on the picture. Okay, so here we go. First thing we're going to do is we're going to try direct substitution. So if I plug in negative 1, I get negative 1 squared, which is positive 1, plus 1 is 2. And then if I plug it in on the bottom, negative 1 squared is 1, 1 minus 1 is 0. Again, we said that if it's a number over 0, it is a vertical asymptote. So this is where a little bit of number sense has to come into play. Okay, so if I'm thinking about it from the left side, that means I want a number that's really, really, really close to 1, but it's not 1, because if I plug in 1, we're going to get the same results. So if I think about it, a number from the left side that's really, 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 really close to 1 would be negative 1.00001. The more ones you can do, the better off and more accurate it's going to be. Okay, so I'm going to plug in negative 1.0001. I'm going to square it, plus 1. I'm going to plug it in on bottom as well. Okay, so my top is still going to give me 2. Okay. But on the bottom, what I need to understand is if I square negative 1.0001, is that number going to be bigger than negative 1 and give me a positive number? Or is it going to be smaller than negative 1 and give me a negative number? Okay, well, when I square it, it's going to end up being bigger than 1. And so when I subtract those two, I'm going to get a positive number, and it's going to be really small. So a positive small number. Okay, well, again, we told you that you can only have 2 answer choices whenever we're taking the limit, and it's a vertical asymptote. It's either going to be positive infinity or negative infinity. So it's a 50-50 chance. And if I have a positive number on top divided by a positive number on bottom, my limit is going to go towards positive infinity. Okay, looking at answer choice B, again, when I plug it in, I get 2 over 0. Again, with our number sense, trying to make sense of it, if I plug in a number that's really, really close to negative 1, then we can actually see what's happening. Okay, so on this one, we're going to pick negative 0.99999. Okay, so and we're not going to have to do this every time if we start to understand the concept of what's happening. Okay, so I'm going to plug in negative 0.9999 squared plus 1. The denominator is negative 0.9999 squared minus 1. Again, my numerator is going to give me 2. And now I need to understand, is this negative 0.999 going to be bigger than 1? Or is it going to be smaller than 1 and I'm going to get a negative number overall? So when I do that, I'm going to get a negative number, which makes my whole fraction a negative. And again, we only had 2 options, positive or negative infinity. But for this one, because we got a negative number overall, it's negative infinity. Now, when I just look at the limit as x is approaching -1, I have to take into consideration that one side of the limit is going towards positive infinity. The other side of the limit is going towards negative infinity. Two different limits going two different ways. So therefore, this limit does not exist because it's not going to the same or going in the same direction. Okay. Looking at answer choice D, same concept, but now we're dealing with +1. So the limit as x approaches +1 from the left side. So when I plug in +1, again, I get 2/0, which tells me I'm going to have a vertical asymptote. So I know that my answer is either going to be positive infinity or negative infinity. Okay, so now I'm going to pick a number that's really, really close to 1. So let's do this one's going to be a positive 0.99999. And when I plug that in, I get 2 on top, but 0.9999 squared minus 1 is going to give me a negative number, which makes my whole fraction negative, so it's going towards negative infinity. Looking at answer choice E, as x approaches positive infinity from the right side, so now I want a number that's a little bit bigger than 1, so I'm going to do 1.00001. So when I plug that in on the top, I'm still going to get 2, okay, over 0, and then again, tells me it's a vertical asymptote, so my answer is going to be positive infinity or negative infinity. So when I plug in that 1.00001, I'm going to get a positive 2 on top, and on bottom, I'm going to get a number that's bigger than 1, so when I subtract it, overall, I'm going to get a positive number. And again, for the limit as x is just approaching 1, if I look from the left side, it's going towards negative infinity. If I look towards the right, it's going towards positive infinity. My limit from the left does not equal my limit from the right. Therefore, the limit does not exist. Okay. If I'm looking at the graph, just to confirm, okay, answer choice A, as I go from the left side, it is going up towards positive infinity as I approach -1. As I go from the right side, it is going towards negative infinity. Okay, same concept with D and E. So as I approach 1 from the left side, it's going down towards negative infinity. As I approach 1 from the right side, it's going up towards positive infinity. The limits do not equal each other, therefore the limit does not exist. Okay, looking at the next example, again, we want to start by doing it algebraically, and then we can always check our work with the graph. So, if I plug in 1, I get 1/0. Again, that tells me that I have a vertical asymptote. So my answer is going to be positive infinity or negative infinity. Okay, so I'm going to pick a really close number to 1, but a little bit smaller, so 0.9999. So when I do that, I get 0.9999 minus 1. It's a negative number, but I square it, which turns it to a positive number. And a positive number divided by a positive number is another positive number. Okay, looking at question B, the limit as x approaches +1 of 1/x minus 1 squared. So again, if I plug in 1, I'm going to get 1/0. So I need to pick a number that is on the right side, so 1.00001. When I plug it in, my top is still going to be 1, but I'm going to have a number that's bigger than 1 minus 1, so it's a positive number. When I square it, it stays positive. So again, I had two options, positive infinity or negative infinity. And when I plug in my 1.00001, I get a positive number. So C, since the limit from the left equals the limit from the right. They both equal positive infinity. My overall limit as x is approaching 1 is also positive infinity. So if I look at the graph, as I approach 1 from the left side, it's going up towards positive infinity. As I approach 1 from the right side, it's also going up towards positive infinity. My limit on the left equals my limit on the right. Therefore, my limit overall is a positive infinity. So, I don't want us to have to worry about doing A and B so we can answer C, or D and E so we can answer F. So we have to really think about what's happening and plugging it in. If you notice, and if you know anything about multiplicities, that can kind of help you narrow down your answer choices. So if your denominator has a multiplicity of an even number, okay, and a multiplicity means that you get the same x value twice if you were to solve for it, then they're going to be going in the same direction. So what that would look like would be like answer choice C. Okay, I'm going to get x equals 1 2 times if I were to solve that denominator. Okay, that has an even multiplicity, which tells me that they're going to be going in the same direction, whether it's positive infinity or negative infinity. Okay, if I have an odd multiplicity, okay, where I don't get, when I solve, I don't get the same x value twice, that means they're going to be going in different directions and the limit's not going to be able to exist. Okay, so if I were to solve this denominator right here, I would get x equals 1 and x equals negative 1. Okay, I didn't get x equals 1 twice, so therefore it's an odd multiplicity. So that's why they're going in different directions, and I got it does not exist. Okay, looking at some more example problems. Find the following limits algebraically. So if I plug in 1, I'm going to get 6 over 0. Okay, so that tells me it's a vertical asymptote. I have the option of getting positive infinity or negative infinity. Okay, so when I plug in a number, I've got to be careful. Now it's giving me the right side first. So 1.00001. Okay, I'm going to get 6 on top still. And then my denominator is going to be positive. So the overall limit is going towards positive infinity. Looking at B as we approach it from the left side. Okay. Again, if I do direct substitution, I get 6 over 0. So now I'm going to plug in 0.9999, okay, a number that's really close. I do know that it's either going to be positive infinity or negative infinity. Okay, so when I plug it in on top, I'm still going to get 6, but when I plug in 0.9999 on bottom, I get a negative number, which tells me it's going towards negative infinity. And because my limit on the left doesn't equal my limit from the right, this limit does not exist. Okay, looking at number 6. Okay, the limit as x is approaching 1 from the right side. Okay, if you understood the multiplicity, that might help you and tell you that it should be going in the same direction. Okay, but if I plug in 1, I get 1 over 0. So I'm going to plug in a number, 1.00001. I'm still going to get 1 on top. On the bottom, I am going to get a positive number. When I take it to the 4th power, it stays positive. So this is going towards positive infinity. Okay, looking at answer or question B. Okay, again, when I try direct substitution, I get 1 over 0. So when I plug in 0.99999 I get a negative number. But when I take a negative number to the fourth power, it turns out positive. So therefore, this is going towards positive infinity. And so my left side of the limit matches the right side of my limit. Therefore, the limit is also positive infinity for that one. Okay. Looking at the next one, we have the limit as x approaches negative pi from the left side now, again paying attention to the small changes. Okay, so this one we will need to actually look at the graph to be able to see. So the tangent graph is going to look something like this. Okay, where this is negative pi over 2, this is positive pi over 2. Okay, something like this. This is going down. Okay, but we're focusing on this asymptote as we're approaching negative pi over 2. So as I approach it from the left side, it is going up towards positive infinity. As I approach it from the right side, it's going towards negative infinity. And therefore, my left side does not equal my right side, so the limit does not exist. Okay, last question, number 8. The limit as x is approaching 1 from the left side of x squared minus 3x divided by x minus 1. So this one's a little tricky, so we got to be careful with it. So I'm going to pick a number that's really close on the left side, so 0.9999. Well, first off, I got to try direct substitution. So when I do that, I get 1 squared is 1 minus 3 times 1, which is negative 2. And on bottom, I get 0. So again, my option is positive infinity or negative infinity. Okay. So when I plug in 0.9999, I get a negative number in the denominator, and a negative 2 divided by a negative number in the denominator gives me a positive infinity. Okay, looking at answer choice B, and I do direct substitution, I get negative 2 over 0 again. Okay, so that tells me my answer is either positive infinity or negative infinity. So when I plug in a number, so 0.00001, on the top, I'm still going to get negative 2. On the bottom, I'm going to get a positive number. A negative number divided by a positive number is negative infinity. So that would be that answer. So write down any questions you may have and make sure you bring them to class so I can